Today is a day of reflection as I think about the news that I heard today, that last night the MP Tessa Jowell, who was diagnosed with a glioblastoma brain tumour in September, died of a brain hemorrhage last night. This is devastating news to family and friends, obviously, and I think about them a lot at this time. And it's also sad as a patient who didn't know her personally but knows her journey very well, as I've known many people who've succumbed to the disease in a relatively short space of time. Now, Tessa Jowell was very vocal about change, and she was in the unusual position of being in a position of power and then being diagnosed. This means that she was able to, as all patients eventually do when they have that diagnosis of brain tumour, you suddenly realise that the system is messed up. The system doesn't allow you to have any opportunity to do something different. And something different is necessary because the standard treatments don't work, and brain cancer remains an incurable disease and is often a disease with a very poor prognosis, particularly with these high-grade gliomas, which is what Tessa Jowell had, rather. Let's be more formal about this. So Tessa Jowell she became a patient advocate in the best possible position because she could actually influence the change that all of these patients and researchers and charities have been trying to do for years, to let people know just how desperate the situation is, that brain tumours have been underfunded for so long, and it's a very unsexy cancer. It's a very unfashionable cancer. It's been neglected for a long, long time, and research is at least 100 years behind other cancers, which is just scandalous, really. It's also a cancer that is the biggest cancer killer of the under 40s. It replaced leukemia a few years ago, I think, just a couple of years ago. And this is just something that a lot of people don't know about, but when you tell them and they become aware of this, they're quite shocked. So it was incredibly sad that it was only when someone in a position of power became diagnosed with this horrible disease that you suddenly saw the funding for brain cancer increase dramatically. Just millions have now been poured into it, but it's so late for anything to happen. It's a great thing, and I'm incredibly thankful, but it's such a sad situation for that to have had to happen for this change. It frustrates me and it makes me sad. And I know that Tessa Jowell was fighting the disease. I don't like to use that term, but fighting it in the right way. I think fighting it by thinking is better than fighting with just willpower, just trying to will it away. Some people say with cancer that, just positive mental attitude and that'll, get you through anything. That's what fighting it is. That's what they think. They think that if someone dies, sometimes it's because they didn't fight hard enough. It outwilled them. But these cancer cells are your own cells, and it's not all about they just go out of control, and it's not all about it's not all about a battle of wills. Obviously, a positive mental attitude can help, and it's a good thing. But you need a lot more than that, especially with an aggressive, very aggressive tumor. And her tumor was very vascular. She had a brain hemorrhage from it. It made me reflect and think that I am incredibly fortunate that I had a brain hemorrhage, and that's how I was diagnosed. And I'm still here today. I'm very fortunate that it was in an area of my brain that, yes, it caused some I'd say minor deficits relative to paralysis and death. It caused me some deficits, but I'm still here today, and I'm able to express my thoughts and have an influence, and I'm in a position where I can do research, conduct my own research to try and find more of these options. And Tessa Jowell did a great thing in Parliament where she stood up and said, brain cancer patients need more options, and many of these options it's about having access, because the system is flawed. The system shows that is such that you can't have access to all of these promising agents that have real potential over and above the standard of care, but you're limited to only having the standard of care, and you're in a double-blind trial where some patients will have the treatment and others won't, but the ones that won't, it's definite that they're going to die because it's an incurable disease. And they'll only have people in these trials with the worst possible situation usually. Usually it's a recurrent glioblastoma and they have to be on the standard of care. If you say no to the standard of care, you don't get to go on most of these trials, and you don't get to have access to these repurposed drugs. Now, these repurposed drugs are often very cheap and very difficult to access, and they're non-toxic, but the fact that they're very difficult to access makes it so that these patients, even if they want these drugs, they have to fight so hard to get them, or they have to go to these clinics in Germany or far out places. They might have to go to America or other places for either an experimental treatment or just drugs like metformin, which has great potential. It works on its mechanism of action is actually on the electron transport chain in the inner membrane of the mitochondria, which is hugely important if you're trying to treat cancer, because with cancer, if you subscribe to the mitochondrial defects theory of cancer, you believe that that inefficiency, if you like, of the respiration, that dysfunction of the respiration in these cancer cells of the mitochondria can be reversed and become as by definition, it's when you have cancer, these cells become more glycolytic. They can use other things for energy, but they become more glycolytic. They ferment, they lactate, and that can be reversible if you believe that the cause is these mitochondrial defects, and that you can alter those defects and those signaling pathways and the hydrogen signaling along that electrochemical gradient in the electron transport chain. You can alter that to then almost reverse those downstream mutations that you see. So Tessa Jowell was an advocate for having these combination therapy approaches using these repurposed drugs to using these repurposed drugs to target all of these signaling pathways in a non-toxic way that often has a metabolic target. That is very crucial, because that is the area that I'm interested in and the area that seems to have the most potential. So it can become extremely frustrating when you constantly see that this is not communicated. So that was a huge thing, that that she was interested in that, and she was in a position of power. I hope that her daughter takes it on. And I found this out when I was trying to get Sativex. As I mentioned in my last video, Sativex is almost a 1-to-1 ratio of THC and CBD. So one of the non-psychoactive compounds in cannabis, cannabidiol, and the other one that I can never pronounce properly, but it's THC. It's the psychoactive compound. If you're treating cancer, you need some THC because that's what often kills the cells, the cancer cells. And the CBD has other properties. I think mostly it's seen as that the CBD is anti-migratory, so it stops the tumour from invading into healthy tissue more. And the THC is more, it's directly targeting those cells, the cancer cells. I'm not an expert in cannabis for brain cancer treatment, but that's kind of how I understand it, even though I don't understand it at all. But it's interesting. I find it very interesting. Mainly I wanted access to this drug to treat some nerve pain that I have as a result of the hemorrhage that I had over 5 years ago now. I wanted to see if that could help, because it can help. It's been shown, it's indicated for chronic nerve pain and for MS. And so I was good to go. I was told I could have access to this drug, and I'd just have to go through a few of these small hurdles to get there. But the last hurdle seemed to be a big hurdle. So I got to that last hurdle. I had approval from my private medical insurance, and my oncologist thought, yeah, this could be a good idea. But then that final person that I had to see said, as I was mentioning earlier, to have access to this drug, I had to have a recurrent glioblastoma, and I had to be on chemotherapy as well. And he has, I'm not going to say who it is, but he has a number of patients in this situation. And it just made me think that even in this situation, which is like the worst possible situation you can have, he was observing patients as kind of observational thing. You can't say it's an unofficial clinical trial, because you can't say that. It would be illegal. But also you can't say that it can be a clinical trial because, I can't remember why, but you can't say that because it's not an official thing and you can't get the funding for it, I guess. I don't know. But it's like this repurposed regimen? It's this repurposed protocol, let's say that. That fits better. This repurposed protocol that he has a number of patients on for observational reasons. And it makes sense, because one of the indications for Sativex is for nausea for cancer patients. It's quite an effective, the THC in it is quite an effective anti-sickness. It has anti-sickness effects. Also has analgesic effects, so it's useful for pain relief. And there's this observation that it could sensitize the tumour to chemotherapy. But I found it interesting how it's not like a double-blind trial where you have some patients having the chemotherapy and the Sativex, and then you have patients who are just having the Sativex or just the chemo. Obviously, you couldn't do that because you're not going to have many patients saying no to the standard of care. But if you did, it would be really interesting, because how do you know if it's the fact that the Sativex is sensitizing the tumor to the chemotherapy, or if it's the Sativex on its own, or if for some miracle the chemotherapy is working, or if it's like a placebo effect, whereby they're in that state of mind where they think this drug is doing what it's said to do, or suggested to do. So that's interesting. It makes you think. It just makes you think about all this stuff. And I'm doing an experiment soon with deuterium-depleted water. I haven't got it yet, but again, it's acting on the electron transport chain in the inner mitochondrial membrane. That's hugely important to everything, especially if you believe in that mitochondrial defects theory of cancer, which is the most compelling theory to me, whereby that impaired respiration in the mitochondria is the cause of all these downstream factors, where you get all these mutations and all these enzymes associated with those signaling pathways going haywire. I believe that you can either target those specific enzymes and use inhibitors for those, many of which are cheap repurposed drugs. You can also have hyperbaric oxygen therapy, drink deuterium-depleted water, and go on a ketogenic diet. Ketogenic diet, if you formulate it well, naturally depletes deuterium from the body, and in cancer, cancer is very sensitive to deuterium. And so it's likely that the water in the mitochondria is high in deuterium, so you're depleting that. It's kind of like a filtering process, filtering that water. I'm not an expert, but that's how I see it. If I get anything wrong, sue me. You're not going to sue me. I just always find it funny with these disclaimers. I'm not an expert, I'm not a doctor. If you follow my advice, it's your fault. Look it up. I don't mean that in a mean way, of course. It's just funny. Because I'm just some guy on the internet, you know? If anything I say, question it and look it up yourself. Because I encourage you to do that. I'm not saying anything. These things might work, they might not. But what have you got to lose? You're in a situation, if you have this disease, where there are no options, and you have to create your own options. You have to be someone who's a human guinea pig. You have to experiment on these things yourself. That, unfortunately, is the situation that we're in. So just be an information sponge, but don't soak in everything. Just take what you need and what you think is important and relevant. Look at a balanced just opinions, and make your own mind up. Get all the information you need, and then decide what you want to take and what you don't, what you think sounds promising and what you think doesn't. There's also, I mentioned in another video of mine, that if you think the ketogenic diet is right for you, you could have a look at your tumour. It'll be hanging around in some lab somewhere, in a dusty corner, in one of those containers, in this kind of fancy area to keep it the right temperature and everything, in this growth medium. You can have it tested. Test it for ketolytic enzymes to see if the ketogenic diet might be useful for you. It's likely that The more solid tumours would be more responsive to it because they're not taking up everything for energy. But yeah, if it's this whole deuterium thing, then it might not be as relevant as we think anyway. Looking at all that stuff, it might be and it might not. It depends. There's ways of assessing status of deuterium in the body anyway, just through, I think it's through mass spectrophotometry. Easy for me to say. I think they do it that way, but I'm not completely sure. I'd looked up an article and it was very interesting, and there are places you can have that tested in the US, but none here. So I'll investigate that. But I will have my water to see what happens to me. I probably won't die. We can laugh at that. I probably won't die, but it'll be an interesting experiment. I don't know if it'll help me, but we'll see. Probably won't have any effect. I don't have any active disease at the moment, so there's no way of really monitoring its effectiveness. But I'm keen to see just how I go on and how I feel, and how my sleep is. Maybe my sleep will get better. How my mood is. Maybe my mood will get better, because high deuterium water is actually heavy water. High deuterium water has a higher atomic mass. I think that's the right way of explaining it. Yes, heavy water, as opposed to light water, which has less deuterium. Yeah, so as I was about to say, heavy water is linked to depression. This high deuterium water is linked to depression. Areas where there's naturally high deuterium, it's suggested that those people have more depression, which is really interesting. I've actually been drinking water that has less deuterium than ordinary drinking water. It's just naturally depleted, but it's still relatively high compared to what I will be drinking is 25 parts per million. That's quite different to about 100 parts per million. So, interesting experiment coming. I shouldn't die. I might be happier because I actually have a history of depression, but the ketogenic diet's actually helped that a lot. It doesn't completely reverse it. I still need to every day work on the mental side, take lots of walks, hopefully in the sunshine. The weather's improving. That's a huge thing for me. I prepare all my meals. I only eat twice a day anyway. I'm doing more exercise at the moment, which is good. Increasing my seizure threshold by looking at heart rate variability and my lactate threshold, going as close to my lactate threshold as I can without having seizures. Sometimes I come very close, which is quite scary. But sometimes you have to do these things, as I said. Sometimes you have to be a human guinea pig, unfortunately. It's not what we want to do, but that's how things are in the current climate for brain cancer patients. You have to be your own human guinea pig. Over the summer, I'm working at Imperial, looking at. They've given me my own mini project, which is quite cool, where I'll be looking at risk factors for glioblastoma. That's not fully established, so if I can make that more concrete, if I can look at proposed risk factors, for example, polyvinyl chloride, we have a number of brain cancer clusters, whereby that's the suggested cause. We don't know, but it seems to be correlated with a lot of these brain cancer clusters. But we don't know. So if I can better determine through in vitro work the degree of causation of particular agents that are known to be carcinogenic, could that help? Could we then translate that to the rodent model and then determine how much of a risk factor these things are? I don't know if that's properly translatable to humans, because rodents aren't humans and they only live about 2 years anyway. But that's all we have. I'm not going to poison any human beings anytime soon, at least. Maybe myself one time, in a fun way. Not fun way. I don't know what I'm saying. I'm not going to poison myself, that's stupid. Non-toxic. Non-toxic agents is what I'm interested in. And water. Water is huge. We have water in all our cells. That's an important consideration. And water has so many effects that we haven't even thought about. I have a really interesting article on water. I'll try and put it down there. It's also very interesting if you're using or interested in using a reverse osmosis machine, because it stipulates in there that in this article, this study, that, well, I guess it's more of an article than a study. It's kind of like a review, maybe. Yeah. It stipulates in there that, where was I going with this? That even if you use this reverse osmosis machine, the problem with that is that you're taking out all the vital minerals in the water. It's kind of like you have dead water in a way. So water is kind of alive in a way, I think. I think I read that somewhere. I don't know how to express that, but water is, yeah, it's just an interesting thing. Interesting molecules. And yeah, you're stripping all the minerals out. So if you're drinking water from that process, you need to then add minerals into it before you drink it, because otherwise it's probably not good for you. It's probably, you're trying to do something that you think is healthy, but it's actually not good. It's the same thing with alkaline water. Alkaline water is potentially high in deuterium. So that's a really bad thing to do. So please don't do that. I know it's quite popular, these alkaline diets and this whole alkaline thing. It's a myth. The whole alkaline diet for cancer thing is just bogus. It's not going to help you. It might even do some harm. It might do you just, yeah, it's not, I wouldn't advise it. I'm not a doctor, but I wouldn't advise it. I'm not a doctor yet. I'll be a medical doctor at some point. I mean, not a medical doctor. I won't be a medical. I'll be a research doctor at some point. But even then, I'll say I'm not a doctor, because I don't want any responsibility from anything, even myself. I'm not responsible for my actions. If I was religious, I'd say it was God. But... well, I guess I don't not believe in God, but I'm not religious. It's perfectly reasonable to believe in some thing that we don't understand out there, because we're so intelligently designed, perhaps, and everything's just very, in such a way that things work with other things in ways that are just extremely intelligent, and just by coincidence it would be, just leaves so many questions. I'm not religious, but all that stuff really interests me. And that's all my thoughts for today. I'm excited about my upcoming experiments. And finally I'm getting somewhere with all this. And it's really sad that people still have to suffer with this horrible disease. But as I said, I'm thinking of Tessa Jowell and her family and all those other people who have little hope. I feel very, very fortunate, very fortunate. Sometimes you can try everything. Tessa Jowell tried a lot of things that I know she did. I know that she tried looking into repurposed drugs and all these other things. She even had the tumor treating fields, the Novacure. It's kind of like a swim cap that you wear on your head, but there's electromagnetic radiation that's, I guess it's tuned to a specific frequency that maybe, I'm not an expert in it again, but maybe has an effect on that electrochemical gradient in the mitochondria to halt that hydrogen signaling that controls growth and proliferation of those cells. I don't know, but that's just a theory of how I think it might be working. I could be completely wrong. You could, like, in the comments say, "You're an idiot, Andrew." Stop being overconfident about things you don't know. There's a lot of things I don't know. I'm definitely not an expert, but I want to contribute to the discussion. And I want to think as a researcher, an emerging researcher. I'm not quite there yet. I'm working on it. I do research, but I want to do more of my own research, and I'm getting there. So, as a researcher, I want to contribute to the discussion. I'm not an authority figure. I'm not an expert on anything, but I want to provoke new ways of thinking. I think as a patient researcher, we think in different ways because we've experienced it. And even the experience of the symptoms can help you to work out some of the potential causes or some of the potential ways of treating disease. And it's hugely important to me to express that and to go to all these conferences and learn from other people who are so much more experienced than I am. And those people who are a lot more intelligent than I am can then listen to me and we can have that conversation, and I can learn from their experience and their knowledge and their wisdom that I don't have, to then marry those two ideas together in something that we can see. That's my dream, that's my aim for the future. And I'll update you on that and let you know how it goes. I hope you're okay. And if you're not, I hope that you do better. I hope that you have health, wellness, and happiness.